All right, Math 135 students, we are dealing with a few examples left over from section 3.1 and 7.2 from our class session on Thursday. This is just to get us caught up. We did a little bit of each of these in class, but we want to get caught up on some of the extra examples in the notes. So this is graphing a system of linear inequalities, and we're looking at two linear inequalities that we're going to have to get into the y equals mx plus b form. Plus we have a vertical line and a horizontal line. So the first thing I'm going to do is go ahead and graph that vertical line x equals 0. And we're going to indicate which direction we should be shading. So this is x equals 0. We're greater than or equal to 0, so we'd be shading to the right. And remember, we want to just mark that with arrows so that we know the direction. We don't want to actually shade yet. We also have the y is equal to 0 line, which is the x-axis. And we're shading greater than or equal to 0 here as well. So anytime x is greater than or equal to 0 and y is also greater than or equal to 0, you're only going to be in the first quadrant. Okay, so that takes care of both of those. Now we want to graph this top line right here. I would subtract the 3x over first, divide everything by 7, so that's going to be, or negative 7, so that's going to be 3/7 x plus 24 over 7, which is not a great number. If you want, you could graph the x-intercept instead and still use your slope of 3/7. If you covered the negative 7y by putting in a 0, that would be 3x equals negative 24. And that's when y equals 0. So that would be x equals negative 8. And again, that's not helpful for us either because that would be over here where we're not even graphing. So it looks like we're going to be graphing the 24 over 7. So let's get a rough estimate of where that is. So 24 divided by 7 is about 3.4. So we'll go to about right there on our y-axis, put our y-intercept. And we're going up 1, 2, 3, right? 1, 2, 3, 4, 5, 6, 7. And we want to draw the line through that. And then we need to determine which side we're shading. If we put in a test value of 0, 0, that would be 0 minus 0 is greater than or equal to negative 24. 0 is greater than negative 24, so that's true. And 0, 0 is down here, so we're going to be shading towards the 0, 0. Okay, and now we have to graph the other equation. We have 3y equals negative x plus 8. Divide by the 3, so that's going to be negative 1/3 x plus 8/3. Again, not the best numbers, so we're going to, but this time if we wanted to, we could use our x-intercept, because if you put in 0 for y, you get just x equals 8. So if you wanted, you could plot this point, and we could do the slope of up 1, left 3. So up 1, left 3. So up 1, left 1, 2, 3. Up 1, left 1, 2, 3. Up 1, left 1, 2, 3. And again, I'm trying to draw the best line I can using this marker. And then this one, if we put in 0, 0, we get that 0 plus 0 is greater than or equal to 8. That's a false statement. So we cannot shade towards 0, 0. We need to shade in the other direction. Now let's talk about what region actually will be shaded. So notice we have this right here where we had to start at the y-axis. This red is pointing towards the black arrows, so that's going to be in the overlap. But down here, we actually have to stop at the x-axis. We can't go below it. So this is the region that we are shading. Now I usually, after this point, take away all my arrows that are not in my shaded region, just because we don't want those to confuse our answer, which is the yellow region. Now, after we graph this and we've shaded in our correct region, There is a follow-up question here. We want to know what if this region is bounded or unbounded, and we also want to label the corner points. Now the corner points you might have to mark. There's this one and this one. These are both our y-intercepts. There's this x-intercept. And that's the only places our graph are crossing each other, where two lines are intersecting each other within our yellow region. We do intersect back here, but it's not in the yellow region. So my corner points are going to be those two y-intercepts we got in our formula. So 0 and 24/7, 0 and 8/3, even though I didn't plot it, that was the 2 and 2/3. And then 8, 0. So those are all the places where we have two lines that we graphed intersecting each other in our shaded regions. This is an unbounded region because it does go on forever to the right. Okay, let's do another one. We've got number 6. This has x is greater than or equal to 0, so we have our vertical line. We're going to be shading to the right of that, so I'm not going to do all the arrows this time. Y is a little different this time, so I'm going to do it in green. Y is between 0 and 2. So we have y equals 2 and y equals 0. And we're shading in between all the way across. Okay, so that takes care of this one and this one. Now we want to graph our other lines. So let's start at the top. This would be 2y is equal to negative x plus 3. So y equals negative 1/2 x plus 3/2. Another way to do this one, though, is to find the x-intercept, which would be x equals 3, and then use our slope that way. So you can do either plot the 1.5 and do the slope, or you can use your x-intercept if it's on your grid. So this would be up 1, left 2, up 1, left 2, and 0, 0 plugged in to see if we're shading towards the origin or away. 0 is not greater than 3. So we can't shade towards the origin, we have to shade away from it. And then my last equation, which we will then graph as an inequality, is the negative 4y equals negative 5x plus 16. If we divide by negative 4, that would be 5/4 x minus 4. There's not a good x-intercept here either, but at least we could graph it because negative 4 is not even on our grid. So the x-intercept would be 16/5, which would be 3 1/5, yes. Okay, so 3 1/5, and then our slope is up 5 over 4. Let me make sure I have that right. That would not be right. That is I said x-intercept and I graphed y-intercept, sorry. I knew that looked funny for a reason. So 16, so that 3 1/5 is here. Okay, that makes more sense. That is our x-intercept because our y-intercept's down at negative 4. So this is up 1, 2, 3, 4, 5 over 1, 2, 3, 4. Graph our line. Now we need to determine where to shade. So we need to put in 0, 0 since that's not on the line. And 0 is less than or equal to 16, so that's true. So we are going to shade towards the origin, which would be this direction. Now what you can see is that because we have this boundary of the y-axis, this is a little bit going out because it's a small region. Let me change the thickness of this. We are graphing, and it doesn't go below the x-axis either, so it's going to have quite a few little corner points because we're having to stop at certain places. So if I wanted to outline this shape, it is here to here to here to here. There's actually a little horizontal part right there. So I have 1, 2, 3, 4, 5 corner points. Okay, so let's write down what we know. So the corner points that we do know are the y-intercepts. We had 0, 2, and we had That is not 1. That was 1.5. It's a little off there. So that's 0, 3/2. This was 3, 0. And that was 16 over 5, comma 0. So that's these. The only question is this intersection point, and you'd be really tempted to say 5, 2, because when we graph ourselves, we don't always assume that. We just want to assume everything's nice points, but that doesn't mean it is. So the only way to know what that point actually is we need to evaluate. First of all, it has to be at a height of 2. We do know that because this is fixed at 2 all the way across. But we need to look at our y equals 5/4 x minus 4, because that was our red line, which is the one intersecting this green line. And we had the equation y equals 2. Set those equal to each other and you'll know what x value that ordered pair is at. So we would add over the 4 and get 6, times both sides by 4, and that would then be 24 over 5. So it is not quite 5, even though my graph looks like it is. So the other corner point is 24 over 5, comma 2. So there's my 5 corner points, and this is a bounded region, because I can enclose the whole yellow part in a circle. It does not go on forever. All right, the last one of these, we have, again, the x is greater than or equal to 0, y is greater than or equal to 0. That usually ends up being par for the course when you're doing linear programming, because you don't want to have negative objects, like negative dog food or negative chicken pounds. We have 3 different linear inequalities to graph, so we'll start with the top one. And here's another thing. If you don't want to do y equals mx plus b, you could just find the intercepts by plugging in 0 for each one. If you plug in 0 for the y, you'll get x equals 5. So that would be the ordered pair 5, 0. If you plug in 0 for the x, you get 5y equals 30. So that would be y equals 6, which would be 0, 6. So that is another way, especially if it divides evenly, to quickly get your inequality graphed, at least the line part. So there's that one. If we plug in 0, 0, that is a true statement. 0 is less than 30, so we are shading towards our origin. We have our second one, which will be y equals 3x plus 6. Again, I could do it by intercepts if I wanted to as well. So this is going to be up 3 over 1, or down 1, 2, 3 over 1. Oh, that was supposed to be negative, sorry. Slope's going the wrong way. When I subtracted over, I didn't write my subtraction sign. So subtract the 3x over and be negative 3x. So that'd be down 3, right 1, down 3, right 1. And this one, if we put in 0, 0, that's going to be 0 plus 0 equals greater than or equal to 6, which is false. So we have to shade away from the origin. And then the last one, which I'm going to do in green, would be y equals negative x plus 4. Or we could get that the x and y intercepts are both 4. But this would be 4, down 1, over 1, down 1, over 1, down 1, right 1, down 1, right 1. And this time we are shading 0 plus 0 is greater than or equal to 4 is false. So again, we're shading away from our origin. So it looks like we have just this little piece. Let's make this thinner so I can shade it in. Between the red and the black here, then the green and the black, all the way down to our x-axis, and we can't go below that. So if we take away some of our other arrows right here, we can see just our shaded region. So we have 1, 2, 3, and 4 corner points. Now, one of those corner points is definitely the ordered pair 0, 6. One of them is the 5, 0. The question is, what are some of the other ones? And we know this one was 4, 0 because that was an exact intercept. What about when the red and the green line meet? So if we don't know for sure, we set those two equations equal. So negative 3x plus 6 was the red equation. Negative x plus 4 was the green equation. Add the 3x over, that would be 2x plus 4. Subtract the 4, that would be 2 equals 2x, x equals 1. And it looks like it has a height of 3, but I can check that as well. I can put positive 1 back into either equation. So negative 1 plus 4 is 3. So the final corner point is 1, 3. And this again is a bounded region. Okay, so that's the end of the graphing the linear inequalities. We had just 3 more slides left to do in section 7.2, and that will allow us to start in 7.3 on Tuesday's lesson. So we did the probabilities of rolling a single die, rolling 2 die, and then we talked about probability from a chart. So now I'm going to be starting with example 4, and it says, in the Great Recession, in a survey conducted by AlixPartners of 4,980 adults, so that's our sample size, 18 years and older, that's just who they are, in June of 2009 during the Great Recession, the following question was asked: how long do you think it will take to recover your personal net worth? This is the results of the survey. So in years, these are their answers. So they thought 1 to 2 years to recover, 3 to 4, 5 to 10, or greater than 10. And this is the number of respondents that answered for each. The first part says determine the empirical probability distribution associated with this data. So we want to add another line here for the probability. So we want the probability of each event. So to find your probability, you have to take the number of people who responded that way and divide it by the total number of people. And we're going to turn these into decimals because the fractions are quite big. So divided by 4,980. This first one is, and we'll go to 3 decimal places, so 0.202. So 0.202. Then we had 1308 divided by 4,980. That's 0.263 if we round to 3 decimal places. 2113 divided by 4,980 is 0.424. And then 553 divided by 4,980 is 0.111. Now, if everything worked out perfectly, which sometimes rounding can get us off, we added those numbers back together, it should equal 100% of our population that we were sampling. So 0.202 plus 0.263 plus 0.424 plus 0.111. Notice that equals 1, which stands for 100%. So that's our probability distribution right there, is the percentages or the decimals or the fractions, however you want to write it. Usually, if everything's pretty big, we'll go to decimals. So if a person who participated in the survey is selected at random, what is the probability that he or she thought it would take 5 or more years to recover? That actually makes them fall into one of 2 different categories. They're either in the group that said 5 to 10 or the greater than 10 group. So we would add those 2 probabilities together since they are disjoint. They don't overlap with each other. People had different answers. So 0.424 plus 0.111. So about 53.5% of the population thought it would take that long to recover their net worth. Okay, so this one's just a practice in listing the simple events associated with each experiment. So an opinion poll is conducted among a group of registered voters. Their political affiliation, Democrat, Republican, or Independent, and their sex, male or female, are recorded. So we're looking at simple events that have 2 categorizations. What is your political affiliation and what is your gender? And usually in WebAssign, they'll have you do these as ordered pairs. So we have a Democrat could be a male. That's one option. And simple events are usually just listed in their own brace. If they want you to list it in one big set brace, it'll usually say S equals. We could have a Democrat and a female. We could be Republican and male. We could be Republican and female. We could be independent and male. Or we could be independent and female. So 3 choices for political affiliation, 2 choices for gender. 3 times 2 is 6 different simple events. Now, as a part of a quality control procedure, 8 circuit boards are checked. So we have 8 total circuit boards, and we're recording the number of defective boards. So you could have a perfect set of 8 and none be defective, so that'd be 0. You could have 1 defective, you could have 2, you could have 3, you could have 4, you could have 5 defective boards, you could have 6, you could have 7, and you could have 8. So mainly this is just trying to figure out what are the different possibilities. Okay, and then the very last one. This says let S equal these 5 simple events, and that's the sample space associated with the experiment having the following distribution. Now there is a missing piece here, but if you know about probability distributions, they should add to 1. So this is 1 plus 6, which would be 7, 8, 9, 10, 11. So we need 3 more to make 14 out of 14, so 3/14. So the probability of event A is the probability, and none of these are overlapping. They're completely, remember, simple events are disjoint. So the probability of being either in S1, which is 1 over 14, or you could be in S2, which is 3 over 14, or S4, which is 2 over 14. So if we add those 3 simple events together as probability, that would be a total of 6 over 14, which reduces by 2. So that would be 3/7. For the next one, the probability of event B is S1, which is 1/14, and S5, which is 2/14. So that would be 3 out of 14, and that one does not reduce. The probability that you have an event, which is the entire sample space, means you add them all up, which means it's going to equal 1, since that is the entire distribution. All right, that gets us to a good stopping point so that we can start back on Tuesday. We will have that 7-3 to do to catch up, and then we'll have some new notes for this coming up week. All right, I hope this helps you guys and you are working through your homework. So let me know if you're having any troubles, and I'll try to answer as many of those questions as I can before we have our class meeting. Thanks and have a good night.